We are graphing linear equations, and this one we will use the slope-intercept form. The slope-intercept form is y equals mx plus b. M is your slope, which is your rise over run. Your b is your y-intercept, which is in the form of 0, comma b. So you're going to plot the y-intercept first. This will be your starting point. From there, you're going to use your slope of rise over run. And I always think of a helicopter when I think of rise over run. Okay, I always think of a helicopter because they have to rise before they run or before they take off to their destination. With your slope, note that if you have a over b, you're going to go up and then right, but the opposite of that is down and then left. And then with our negative out in front, you can place that in the numerator, which would be down, then right. Opposite of that is up, then left. So that negative can go in the numerator or denominator, and you can perform the opposite operations. A positive slope, the graph is going uphill. A negative slope, if your number is negative, it's going downhill. Okay, so let's go ahead and practice graph y equals 4x plus 1. So first we're going to identify the slope and the y-intercept. So slope is 4, and to create this as rise over run, we are going to place a 1 underneath it. So we're going to go up 4, right 1. The b, or the y-intercept, is going to be 1. So on our graph, and I realize I need more tick marks there. We are going to be at the intercept of 1 on our y-axis. That's our starting point. Then we're going to go up 1, 2, 3, 4, and right 1. And then I run out of room, but I can go back to my starting point and go down 1, 2, 3, 4, and left 1. So make sure you have at least 3 points and use a straight edge to create your line. And please be sure to extend your line all the way past the edges of your graph, because this way we are hitting every single point that is on the line inside the graph, and we're saying that it goes beyond the graph. Y equals 5 over 2x minus 6. So the slope is 5 over 2, or up 5, right 2. And the y-intercept is negative 6. So to graph it, we start at negative 6 on the y-axis. So 1, 2, 3, 4, 5, 6. That is our starting point. So from there, we are going to execute our slope. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 1, 2. Make sure you have at least 3 points. And you are going to draw a straight line using your straight edge to go all the way through. And hopefully you have some graph paper you can use instead of drawing like I have. Y equals negative 2/3 x plus 2. The y-intercept is 2, and the slope is negative 2/3. So to graph, we find 2 on the y-axis. So here's 2, and we go down to right 3. Down to right 3. And as you can see, our line is going downhill. Well, that's because our slope was negative. On these other ones, both of our lines were going uphill because our slope was positive. So that's one way to check to see if you've gone the correct direction on your slope, is to check to see if your lines are going the correct way with what your slope is saying. If you start out with a problem that looks like this, and 3 and 2 can go into a 6, you can always use intercepts instead of solving for y. So y-intercept, if you solve for y, we get negative 3. Our x-intercept, if we solve for x, we get a 2. So we have negative 3 on the y, 2 on the x-axis, x-intercept, and there's our line. Now, if we had a line, let's say we have 9, and we can't find our intercepts because 2 can't go into 9, and I don't really like to graph fractional answers unless you skew the graph to where you're counting like every half instead of every one being by 1. You can do that, but in a typical graph, we tend to go 1, 2, 3, 4, 5, 6, count by 1s instead of halves. Sometimes we count by 2s. So anyway, you can still find the x-axis or the x-intercept, which would be 3, 0. Solve for x, you get 3, 0, or x-intercept, you can write it this way, equals 3. Now to find all the other points, or at least find your slope, you can't work this, or you can't do this in the standard form. So let me go ahead and plot that x-intercept while I have it. So what you're going to do is solve for your y. So we're going to subtract 3 over, or the 3x over. So we have negative 2y equals negative 3x plus 9. Then we're going to divide by negative 2. So y equals 3 over 2x plus, or actually that's going to be minus 9 halves. There is your y-intercept. Like we said here, we could not find our y-intercept because it is a fraction, and it would be 4.5 or negative 4.5. And I don't like to graph the fractions. So here is our slope. We have one point already on the graph. We can use that point as the starting point to execute our slope. Okay, so there is another way you can work the slope and intercept, or y-intercept, and in this case it was the x-intercept we went ahead and used to graph this line. Okay, so you can use the slope and y-intercept if it's in y equals mx plus b. If you can identify that you can use your intercepts, do so. Here we could only use one intercept. Go ahead and do that, and then solve for y to find your slope. And as you can see, it was 3 over 2, not negative 2, but positive 2. So it's actually, this one here would be 3 over 2 as well. As you can see, we go 1, 2, 3, 1, 2. So that is one little trick you can use. You take your coefficient of your x over the coefficient of your y, and then you negate that answer. So this would actually be positive, it would be negative, but that's just a little FYI. I don't typically use that a lot because I'm afraid I'm going to mess up the order of my numbers here. So when in doubt, just solve for y and then use your slope and go from there. This concludes this video.